Hey guys, we're back again with the Hysolis Apollo 5K portable power station. This is the unit we reviewed in quite a bit of detail last week and did some testing on. This video will be focused on the inside of the unit. We'll do a teardown to see how it's built and the choice of cells inside. So we're gonna get straight to it. Don't forget to smash that like button before we get started. All right, so we're gonna start on the side of the power station that has the two large battery connectors. And we're going to do that because that's the side the BMS is on, the battery connections. And there's also a component in there that you may actually be servicing yourself. So to remove this cover, there's a series of 6 Allen head screws. These are 2.5 millimeter. With those screws removed, we should be able to wiggle off underneath. There you go. Put your hand underneath and pull it. Okay. All right, so I've looked over this just a little bit here, and this is actually pretty impressive how nicely this is laid out, how cleanly all these cables are bundled. They've taken some safety precautions here. So the first thing worth mentioning is that that cover is designed to be user removable by you, the customer. And the reason for that is over here on the top right, we have our ground neutral bond. By default, these units ship with this conductor attached to a plastic bushing. It says here that the neutral ground bond is separated, so you have a floating neutral in this configuration. And this is fine under most operating circumstances, especially if you're using this as a portable unit. However, there are times when you may want the neutral and the ground bonded. In standard US power, that's typically the case. It's typically only done at one location, your main service panel, your main disconnect, wherever that may be. So if you decide, or an electrician decides that you need to have a ground neutral bond, you can simply unscrew the wire from here and screw it into either one of these two places. That's going to tie the two together, and now you have your ground neutral bond. We have an RS-232 communications cable here. Appears to be an RJ45 connector. We have an RS-45, a USB port there. I'm going to guess that's probably where they flash firmware. We have COM1 and COM2, which are going to the two communications ports there on the front, straight down. And then I mentioned there's a few rather neat safety features here. So because this cover is designed to be user removable, we have a plastic cover here covering all of the battery components. So that's a great safety feature to prevent accidentally coming in contact with any of that. Of course, you really shouldn't come in contact with any of the stuff up here either. So let's go ahead and get that plastic removed just so there's not a glare on the screen here. And for doing that, you'll need a 5.5 millimeter socket. So now we can take a closer look at our BMS, which is upside down here. Model number SNT CNBMS00160V2. It is labeled by Hysolis, so when I looked up this part number online, I couldn't really find much, so they may have had this made specifically for this application, but there's a very nice wiring diagram here. We have RX and TX, some sort of communication LED. We have RS485 A and B. We have CAN, high and low. So this has all sorts of communications protocols here. We have these pins labeled K1 and K2. I don't know if maybe they're temperature sensors. Oh, no, these are going to be the temperature sensors up here. They are labeled T1, T2, T3, and T4. So it looks like there are 4 temperature sensors feeding this BMS. And then these other colored leads here are going to be our balance wires. This does say 16S here, so we know this is 16 cells in series or a standard 51.2 volt configuration. We have a large inductor here, presumably for current limiting. These are the main terminals coming off of the battery here. We have the main positive, which is coming down through a 150 amp. I believe that's a mega style fuse, mega fuse. We have the main negative coming off, which is going through a rigid bus bar in some, I don't know if this is braided nylon type material here. This is going into the B- side, or the battery side, and it's coming out the C- side. C standing for common, meaning charge and discharge. We also have this red lead coming out of the positive before the fuse going into the BMS. That's the B+ here. That's going to provide power for the BMS itself. So we have some main bus bars here. We have the positive and the negative. Now this is all done with 6-gauge silicone insulated wire. That is wire with a 200 degrees Celsius insulation rating there. And you can see we have 3 connections for both the positive and the negative. Actually, there's 4 rather if you count the ones on the left. So this is power coming in from the battery. And then we have 3 leads coming out of each bus bar. We have one set of leads going to both front connectors there for the battery connectors. And then the third lead is going up to the inverter charger. Now this is why I noted that you'll want to connect that battery parallel cable if you're going to be using multiple of these inverters, because all that's doing is it's simply connecting all of the batteries in parallel. There is nothing in the way between these units other than the BMS operating on this battery itself. Everything you connect to those battery terminals there is simply dumped into the main battery connection point, which is this positive and negative bus bar. Now that does allow for ease of use if you want to build your own expansion battery. Now that is not recommended by the manufacturer, and I don't recommend it either. Additionally, if you were to do that, you wouldn't have communications between those extra batteries, because as you see here, there's a communications lead going to each one of those external connectors. So before we go any further here, I'm going to remove this fuse here just to de-energize this system and make it a little bit safer. As I noted, this is a 150 amp fuse. Quick safety check here. There is no voltage present. No voltage present there. To remove the top cover, there are 4 screws located on each side. And there is one connection underneath here, which is going to the wireless charging pad for a wireless phone charger on top. So you'll need to disconnect that. With that top off, we can really get a good look at some of the internals in here. Now, one thing to know before I start moving cable ties is how nicely laid out these wires are. They're all secured down and nicely bundled. Proper wire management like this really is an art in itself, and it takes a lot of time to get right and to get organized. And they've really done a great job here. Everything is very neatly routed. I don't see anything that looks inherently unsafe. Even the conductors are ran through protective insulation the whole way. So this board here is the DC-DC converter for the system, and this is going to be what steps up the 12-volt input to charge the battery, and it's also going to be what steps down the 48-volt battery to your DC outputs. So over here on the right where we have our DC charger, that's going under the board and it's coming in here on the left. Then we have our primary 48-volt battery conductors coming out and going down to the battery. On the lower left here we have all of our 12-volt outputs. They're coming out, going up and around, and they're feeding our cigarette lighter socket, our Anderson connectors, and then there's a set of them going down to this first PCB printed circuit board, which is feeding all of the USB ports on the front. On the right side of the DC-DC converter, we have 2 pins going to a cooling fan here, which is blowing air over all of the heat sinks. It's nicely positioned. And then there's an additional 2-pin here on the bottom right that I'm not quite sure where it's going to just yet. And I also see this little 2-pin connector right here is an RS-485 communications cable. So this unit as a whole does have communications to this DC-DC converter. Most of these are removable connectors. This is a, the name's escaping me at the moment here, an XT60. This is an XT60 connector, and our battery side is an XT60 as well. There are 4 screws holding the DC-DC converter in place, 2 located on each side here. And there were 2 screws I had to remove from this location and this location as well. I should be able to simply, wiggle this out like so. You know what? I bet I have to take off this top support beam, which I see is held on by 2 screws on the right and 2 screws on the left here. So let's do that first. All right, before we get in the top any further, let's break down some of the wiring we have here in the front. So I removed these zip ties. We have this small circuit board, an RS-485 splitter. Based on how these connections are done, we have an A and a B coming off here, going back to the main computer, the display mount here. And then we have a series of smaller cables. So these 2 are going down to the battery connectors. These are the communications for the battery. And then this last one here, off the bottom left, is going down to the BMS. And that is in both the CAN and the RS-485 ports. So we can go ahead and pull off some of these here. So we have our communications from the DC-DC converter that's going back to the display, and we have our mystery 12-volt supply here that was coming off of the converter, also going back to the display unit. All right, so on the right-hand side here, we can see our main power input. It is grounded to the chassis of the power station. The one leg is going down to what I noted in the original video looked like a circuit breaker. It is indeed a circuit breaker rated for 40 amps down there. And then both of those leads are going down to the inverting circuit board down there. All right, so taking a look at this board looks somewhat similar to some of those that we've pulled out of the MPP Solar lineup of inverters. It doesn't look the same as anything in particular, but I see a lot of these same components, and I don't just mean performing the same function, just the board layout looks similar. Starting on the right-hand side here, we can see this green block is our battery positive and negative input. There's a set of screw terminals there holding it down. Then again, the smaller lead coming out is going to the DC-DC converter. This is our output line and neutral going around and going down to the front receptacle we'll take a look at a bit later. This vertical and then horizontal board we see here is managing the communications, and I also believe it to be the control board for the inverter charger itself. Towards the back of the board here, we see these 2 large inductors and these 2 large capacitors. This is going to be the high voltage DC side of it. And that's also consistent where the PV input is coming in on the back left here. There are quite a few connectors here I'm not particularly familiar with, like this one here that says battery SPS is jumping directly to the other side of the board. Sometimes these boards are physically separated to keep high voltage components separated. And there is a lead down there labeled AC SPS, which is going back to the AC input from the grid down there. And then the dead giveaway for all this that makes this look similar to some of the boards I've pulled out of the MPP inverters, indicating that perhaps this board was manufactured by Voltronics. Again, that's just my complete speculation, is that this ground neutral bonding wire here. So that bonding wire there is actually soldered to the circuit board in the spot where the grounding screw usually goes. And you can see there on the side there is a ground screw indicator. I also see a number of temperature sensors in here. So we've got one on each heatsink essentially. So there's one on this heatsink here. We've got one on this heatsink here. It's that white cable going down there. And then we've got another on this heatsink underneath there. Again, it's the white cable coming out. Again, we can see our solar input cables going up to the charging circuit there on the right. We have the main FET transistors here. And these are part number IRF 84110. There is a specifications label here on the side, model number UQ-S48105. 105 amp hour, 51.2 volts as we already noted. Max continuous charge and discharge of 100 amps. And down on the very bottom here, we just have a warning label from Hysolis, but the one thing worth noting is the bottom right. The manufacturer date was 7/23. That is July of 2023. So there we have our grounding rod connector. It is grounded to the chassis of the power station in 2 locations. One is right over here, and the second is all the way back in there to the bottom of the support bracket for the inverter board. So this is going to be our LED, our alarm run and state of charge indicator here, and that long ribbon cable comes all the way up here on the other side, goes back down, and it's entering the BMS right here on the LED tabs. Also worth noting is the main AC output for the RV style connector down there. They are all screw terminals. You can see there's wires going in, which is the AC feeding it in, then a second set coming out, going over to the circuit board on the right here, which is where the 20 amp receptacles are soldered into place. Wiring seems more than sufficient. Again, it's all protected. Now again, many of these connectors are tightened down with screw terminals, and I've either checked the screws or given them all the tug test, and I haven't found any anywhere that are loose. I do want to see if I can pull this battery out, and I'm hoping I don't have to take out all of this inverter stuff and all those connections, because the problem's going to be remembering where all those go back. It looks like this battery is in this black cage, this black metal cage, and then it's also in a silver cage. So I'm hoping that I can remove these 3 screws, these 3 screws. I see there's one maybe down here. And then slide the whole thing out the other side. So I'm going to try that, see if I can pull the battery out. And obviously I will have to disconnect all of this and all of this. But however, the battery is the most interesting part of the power station for sure. So we definitely want to pull it out and see what we have in there. All right, so one thing to note here is that these bus bars are actually aluminum. They're not copper. There's nothing wrong with that. Aluminum is a perfectly valid conductor, and they are plenty thick. So with those removed, it looks like the battery will slide forward now. Just have to make sure nothing else is... Oh, all these BMS leads have to come off. My mistake here. So let's go ahead and do that. Go ahead and try that again here. In the way. Oh. And that battery is by far the heaviest part of this power system. That thing is so light, it just feels comical to pick up right now because of how light it is. All right, so here we go. And they are Eve cells. They are Eve cells. So that is model number 04Q CB6531900J. So 04Q typically stands for Eve, and I can tell by that in combination with the vent and the terminal style. These are Eve 105 amp hour cells. These are aluminum bus bars, and you can see they have the classic hump in the center to allow for expansion. They are laser welded into place. The laser welds appear to be done very consistently and cleanly. There are also Phillips screws on each terminal. The Phillips screws are not holding the bus bar down. I'm guessing those were just there. Well, they would have had to do the laser weld first based on how this looks. So perhaps they just put them in there for extra strength. I don't know. In some cases they make sense because they're holding down the balance leads, but why there's some in areas where there are no balance leads, I'm not sure. Speaking of balance leads, they are all individually numbered. This one says B12+, this one says B14+, etc. They are terminated with ring terminals with heat shrink, and they are screwed down to the bus bars. Over here we have one of our temperature sensors. You can see this one says T4. The balance leads are all routed up the center channel. They're zip tied into place. There's no excessive length, no wires flopping around, nothing like that. Let's see if we can find the other temperature sensors. I see T1 is located right here. On the top I see T3 is here, and I see T2 is over here. And I don't actually see any material separating these cells other than the heat shrink on each cell. I do see there's a separator running across the two rows here in between them, but I don't see anything between the cells themselves. These cells are fixed in a very nice steel enclosure here. It might be a little bit difficult to see on camera here, but the entire battery, maybe you can see it there, is lined with foam, insulating the battery from the case itself. So we've got the whole thing put back together. See, my wiring is tidied up a little bit, but it's never as neat as when it comes off. So it's time to go ahead and give it a try and see if it starts up. Press the battery button. All right, appears we've got power. And it doesn't appear to be connecting, so I need to troubleshoot what I may have missed here. So the power station is working again. It ended up there were two small connectors on the DC-DC converter I had switched. The fan connector and the 12-volt supply for the front. So once I put those back, it started up perfectly fine. All right, so as expected, the insides are very clean and neatly organized. It's a great choice of cells. Eve has a fantastic reputation, and they're my personal favorite as well. If there's anything else you guys like to see, we might do one additional video with this unit yet, please do let me know. Hit that like button before you go. Any questions or comments, you can leave those as always, and thanks for watching.